Hello friends, welcome to Learner's Planet. Friends, in the sequence of logical reasoning sessions, we are going to discuss Venn diagrams in this session. Good number of questions from Venn diagrams used to come in various entrance examinations. So first of all, let's discuss the basics of Venn diagrams, then we will proceed for the problems, right? So first, let's discuss some basic terminologies related to Venn diagrams, right? Here, the first thing is sets. Now, what are sets? Sets is a set is a meaningful collection of data. Meaningful means it should convey a sense, right? Suppose a set of natural numbers, a set of positive integers, a set of integers, set of whole numbers, a set of your family members who live in a particular premises, a set of students in your class, right? So all these sets are like a meaningful collection, right? Why I am calling a meaningful collection? Because if the collection is not meaningful, the data cannot be predicted. The elements of the sets cannot be predicted. Suppose I tell set of beautiful persons. Now, what is the criteria to define a beauty, right? So it's not a meaningful collection. Similarly, set of intelligent human being. Now, what is the criteria or what is the basis of intelligence? So further, it is not a meaningful collection of datas. Now, to solve the problems of Venn diagrams, some basic other terminologies are also important. What is finite set? Finite set, that means number of elements can be counted, right? That means there is a countable number of elements, right? Suppose students in your class. If I talk about students in the world, that set cannot be, the elements cannot be counted. So that is an infinite set. That is a set, but that is an infinite set, right? So students in your class, so number of students in your class can be counted. So it's a finite set. Similarly, the set of integers is infinite because there are negative integers, positive integers, and we do not know extreme integers. That means which is the biggest positive integer and which is the biggest negative integer, right? So we do not which is the least negative integer, so we don't know them. So that's why the set of integers as well as the set of natural numbers is infinite. But if we talk about positive integers less than 100, that we can count. So what will be the positive integers less than 100? It is from 1 to 99, right? So 99 elements will be there. So we can count that number of elements in the set is 99. So it's a finite set. Now suppose we have the sets of natural numbers and integers. Since we do not know the extreme numbers, we cannot count them. How many natural numbers are there? There is no answer to this question. But the set is meaningful that we are counting natural numbers, and that is a systematic set. That's why it's a set, but it's an infinite set since the elements cannot be counted. Similarly, if I talk about the number of males in your city, the set is well defined that you are wish to count the number of males, but still it is an infinite set because it becomes really difficult to get the exact number of males in your city, right? So that is an infinite set. So you got the difference between finite set and infinite set, and you are clear with the definition of sets as well. Now let's discuss some more terminology. Now, what's an empty set? Empty set, that means in a set if there are no elements, if there is no elements, then we can call it as an empty set. Suppose I wish to a set that is defined maybe a natural number between 2 and 3, right? Now natural numbers means what? These are full numbers, whole numbers, right? And between 2 and 3 there is no natural number. So the set of natural numbers between 2 and 3 is an empty set, right? Because there is no element in this set. Next is Singleton set. That means a set in which only a single element is there. Suppose you have a family of 4 members, your father, mother, and one of your sisters. Suppose there are 4 members, father, mother, a son and daughter. right? So this is a family. The son is of son and daughter. Now, what we suppose if I ask about a married woman in the family, a married woman in the family, then there will be a single element, that is mother, right? So it's a singleton set. If I talk about married male in the family, then further there will be a single element, that is there is father. Suppose if I talk about unmarried members in the family, then there will be two elements, that is son and daughter, right? So this set of father, that is male member, male married member is a singleton set. Female married member will also be a singleton set, right? Finite and infinite we have already discussed. Now union of sets. If we club the various sets, that is called to be a union. Suppose I have a set A. In this I have elements 1, 2, 3, and if I have a set P in which the elements 3, 4, 5. So union of set, how do we represent that? That is A union B. That will be all the elements from A and B taken for a single time, right? No repetition should be there. Now we see elements in A are 1, 2, 3. And elements in B are 3, 4, 5. 3 we have already taken, so now 4 and 5 will be there. We will take each and element once only. So A union B is 1, 2, 3, 4, 5, right? So all the elements of A and B come in this set, right? So this is union of sets and we represent it as by U, right? Say one more example. Suppose I have a set 1, that is S1. In this I have odd numbers from say 1 to 100, right? And second set is even numbers from 1 to 100, right? Now what will be their union, right? That is presented as S1U S2. What will be the union? All the odd numbers as well as even numbers from 1 to 100. So what the answer will be? 1, 2, 3 till 100, right? That means the natural numbers, or we can say the positive integers from 1 to 100 both inclusive, right? So this is set S1, this is set S2, and this is set S1 union S2. So that is from 1 to 100. So that is union of sets. Similarly, the next term is intersection of sets. Intersection of sets is the common thing between the two sets. Like whatever the elements which are common between two sets are intersection. We represent that by the reverse U, you can say this U, the water image of this U, right? So S1 intersection S2, right? Now if we talk about these two, right, the set S1 is odd numbers from 1 to 100 and set S2 is even number from 1 to 100. Now what would happen over here? The number which is odd cannot be even, the number which is even cannot be odd, right? So there are no common terms between these two sets. So S1 intersection S2 will be 0. It will be a null set. You don't write 0 over here. It will be a null set, right? Null set if there are no elements in the set. If we put 0 like this, that means there is one element, that is 0, but there is no element, so do not put anything in between. Students get confused between this and this. This is an element 0 over here, but actually S1 intersection S2 is a null set. There is no element, so just put it like this. Okay, now I take one more example. Suppose I have a set S1. Here the set S1 is defined as even numbers less than 10, right? And set S2 is prime numbers less than 10, right? Now what is S1? Even numbers less than 10, that is 2, 4, 6 and 8, right? what S2 is prime numbers less than 10, so it will be 2, 3, 5, 7. Right? Now suppose I have to find out intersection of sets. What I will do, what are the numbers or elements which are common between the two sets? That is a single number, that is number 2. Right? 2 is even as well as prime. So S1 intersection S2 will be a single element, or we can say a singleton set having a single element, that is number 2. 2 is even as well as prime, right? So you are clear about intersection of sets. So this is intersection of sets. Now next is difference of sets. Difference of set, that means suppose I have a set A, the elements are 1, 2, 3, 4 and 5, and I have a set B with the elements 2, 4, 6, 8 and 10. Now difference of sets is what? A minus B, right? Now what A minus B will be? The elements which are there in A but not there in B, right? So we have to eliminate the elements which are there in B. Okay, so 1, 2, 3, 4, 5. 1, it's clear. 2, 2 is in A but that is in B also, so we will not take this, we will not take that. Next is 3, 4, again 4 is there in B also, so it won't be. Then 5. Okay, so we have to take the elements which are there in the A, in the set A, but that is not in the set B. So A minus B, that is difference of A and B. Okay, so that will be 1, 3 and 5. Similarly, if we have to calculate B minus A, see A minus B and B minus A in this case will not be same, because in the case of sets, now we have to take the elements which are there in B but not in the set A, right? So it's 2, it's there in B but it's there in A also, so we want take 2. Similarly 4, it's there in B and it's there in A also, so we won't be taking this. Now 6, 8 and 10, right? So what is the answer to A minus B? That is 1, 3, 5. And what is the answer to B minus A? That is 6, 8 and 10, right? So A minus B and B minus A, both of them are not same, so do not get confused, right? So this is what difference of sets. Now next is subset of a set. Now what is subset of a set? Suppose I have a set A, that is 1, 2, 3, and I have a set B, that is 1, 2, 3, 4, 5. Now we see all the elements of A are there in B, right? And B is having more elements than A. That means all the elements of A are there in B. That means A is the subset of B. So we represent it as A is subset of B. Now next is disjoint sets. Now we discussed about intersections and now we are going to discuss about disjoint sets. Now what are disjoint sets? The sets which are having no common datas, right? Suppose set of A is the set of even numbers and B is set of odd numbers. Now there is no common term between these two, right? Suppose A is the set of even natural numbers and B is the set of odd natural numbers, right? So the sets A and B are known to be disjoint because there are no common elements between the two, right? Similarly, now one more example. A set of your male friends and set of your female friends, right? So both the sets are disjoint sets, right? We can take more examples. Set of engineers, just a common examples I'm taking. Set of engineers and set of doctors. So both of them are disjoint set if we take at a common interpretation. So a set of doctors as well as set of engineers, both the sets are disjoint sets because doctor is not engineer and engineer is not doctor, right? In general I'm talking about. Do not take the exceptional cases. Now next is equality of two sets. Now, if the two sets are having same elements as well as same number of elements, then we call them as equal sets. Suppose set A is 3 elements, 1, 2, 3, and set B is also having 3 elements, that is 1, 2, 3, then we call them as equal sets. That means A is equal to B and B is equal to A, or A is subset of B or B is subset of A, right? Equal sets are subset of each other. Okay, so these are some basic terms which we discussed so far. While we will be solving the problems, we'll be discussing more such terminologies, right? So let's take some problems. Before taking problems, I just would like to explain one Venn diagram also. Wait a moment. Now, let's discuss about Venn diagrams. Venn diagram, it's a circular representation of sets, right? A diagram that shows all possible logical relationships among a finite collection of sets, right? We represent Venn diagrams by circles. Now, this is a combination of two circles. So this is suppose set A, this is set B, and this is like a common portion, that is A intersection B, right? That is the numbers or the elements which are common between A and B, right? So this is Venn diagram that is showing the relationship between A and B. Similarly, this is a Venn diagram that is showing the relationship between A and B. Here A and B are disjoint sets. That means no elements are common between A and B. So these are disjoint sets, right? Now this Venn diagram, this is a superset and these are two sets inside this set, right? I take an example, suppose A, it is set of natural numbers less than equal to 100. Now set B, even numbers less than equal to 100, and set C, odd numbers less than equal to 100. Now even number and odd numbers, both of them are actually natural numbers. So this is the circle of natural numbers. Or we can call the set A. Now these two are disjoint sets, right? Because the set of even numbers and set of odd numbers, there are no numbers common between the two. So these are disjoint sets. This is set B and this is set C. Now set B and C, both of them are subsets of set A. That means all the elements of set B are there in set A and all the elements of set C are there in set A. So sets B and C, both of them are subsets of set A. So we represent B and C as subset of set A, and since B and C there are no common elements between these two, so these two are disjoint sets. So while we will be discussing the problems, you will be more cleared, right? So let's start taking some problems now. Now let's take some problems based on Venn diagrams. Here, see, there are 5 options given, A, B, C, D, E, and different types of presentation of circles is there. So we have to find out which option represent the questions, right? Or the terms which are given to us, or we can say group of things, right? Given question contains 3 groups of things. Choose the correct diagram that depicts the correct relationship among the 3 groups of things, right? Now there are in this 3 sets, and 3 sets are connected to each other. These 3 are the disjoint set. That means there is no relationship among the 3. In the set, 2 things are related. The one thing is subset of other thing, and the third thing is disjoint, that is no relationship, right? Now we take this example, and with this example I elaborate each and every option, right? Now we take vegetables, fruits and brinjal. Now vegetable and fruit, both of them are different from each other, or we can say these are disjoint sets. the vegetable is not fruit and fruit is not vegetable. Am I clear? Fruit is not vegetable and vegetable is not fruit. So these two are disjoint sets. Now brinjal is what? It's a vegetable, right? Now brinjal vegetable is a superset. That means all the vegetables can come in, right? So vegetables is a superset and fruits is also a superset, but that is apart from this set, or we can say vegetable and fruit are disjoint sets. So I draw two disjoint sets. Now where will brinjal come? Brinjal is nothing but a vegetable, isn't it? So all brinjals will come in the set of vegetables. So these are brinjals. So this is the set of vegetables, this is the set of fruits, and this is the set of brinjal, because brinjal come in vegetables. Okay, so this is the presentation of vegetable, fruit, and brinjal, and over here this is shown by option C. So this is the correct choice for vegetable, fruit, and brinjal. Option C is correct. I hope you are clear. Now next is door, window, and house. Now doors and windows, both of them are part of house, right? So both of them, the house will be superset. That is this circle, that is house. Now doors and windows, these two are disjoint sets, because door cannot be window and window cannot be doors, but both of them are in house. Or we can say they come in house, right? So doors and windows, they are subset of house, but they are disjoint sets. So these are doors and these are windows. Nothing is common between these two, right? But they come under house. So these are doors, these are windows. So the representation same as this is option E, right? I hope you are getting me. It's not that difficult, you just have to apply the common sense, and after some practice you will be doing it very easily, right? Now the next example is honest, intelligent, and poor. See, these three terms are individually true and there is no superset, right? So what the idea is, honest person are intelligent also, and honest person may be poor also, poor may be intelligent also, and poor may be honest also. So all these three terms are related to each other, right? Now if they're related to each other, that means a person can be there which is who is honest as well as intelligent as well as poor, and a person will be there, can be there, that who is honest only but it's not intelligent and poor, right? So some datas will be common and some will not be as common, right? Some elements will be common but some will not be common, right? So this is option A. There are, I just draw it over here, honest, intelligent, and poor, right? So this is honest, intelligent, and poor. Now this area, just wait a moment. Now this area represent the persons who are honest as well as intelligent. This area represents the persons who are intelligent as well as poor, and this area represents the person who are honest and poor. Now this area, that is this area, represents the person who are only honest, neither poor nor intelligent, only honest, right? So there will be some persons who are only honest but neither intelligent nor poor. Similarly, this area represents the person who are intelligent only, neither honest nor poor but intelligent only, right? Similarly, this area is there which are the persons who are poor only, neither honest nor intelligent, right? So this is the area of only poor but neither honest nor intelligent, right? So this sort of persons will also be there. Similarly, this area, that is the central area, this area is the represent the persons who are honest, intelligent, and poor, all of them as well, right? That is, they are carrying all the qualities of being honest, intelligent, as well as poor, right? So this is the true representation of these three datas, these three group of things, right? So I hope you are clear. Friends, we have discussed some concepts and some 2-3 problems in this session. We'll be taking more problems based on Venn diagram in our next session. Till then, do revise this session. Bye-bye.